we conclude this chapter with two types of errors, and we'll have one practice problem. So let me read what's going on here. After performing the test between hypotheses and making our decision, we will not know with absolute certainty if we got it right. So just think about, right, like, in the courtroom, right? So the jury doesn't know if they got it right or not. They are only based this on their best guess. Did they have enough evidence to put the person in jail? And if they convict, they don't really know that the person actually did it, right? They might have gotten it wrong, or certainly if they don't have enough evidence, right? The defendant still could have been guilty. So no one really knows in the end, as far as the jury. Okay, so we must consider the consequences if we happen to be wrong. This is big. So we're going to label these. There's two types of ways to be wrong. So we call them the type 1 error, where the null hypothesis is true but ends up getting rejected, and the type 2 error, where the null hypothesis is false but ends up not being rejected. Okay, so let's see how this plays out in an example, and then we'll do one together. So in the example you see there, Frank is unsure if his rock climbing equipment is safe. By the way, all of these examples we see with the errors, they're always life and death, because we want to make it really, really clear the consequences if we get this thing wrong. Okay, so Frank, he's unsure if his rock climbing equipment is safe. So he determines this null and alternative hypothesis. He says null hypothesis is that Frank's rock climbing equipment is safe, and the alternative, that Frank's rock climbing equipment is not safe. Okay, so based on those two hypotheses, let's consider each type of error. So the type 1 error, again, this is when the null hypothesis is true but ends up being rejected. So if that's what's happening, then we'd say the rock climbing equipment is safe, right? That was the null hypothesis. So the reality is his equipment is safe, but he ends up deciding that it is not safe. So the type 1 error, the null hypothesis is true, but it ends up being rejected. Okay, the type 2 error, the null hypothesis is false, but doesn't end up getting rejected. So that would mean, if the null hypothesis is false, that would mean the equipment is not safe, but it ends up being decided to be safe. And what we're always going to be asked with these is, which error has greater consequences? Okay, does the type 1 error have greater consequences, or does the type 2? And because it's life and death, right, it should be really, really clear. Okay, so again, let's look back at those. So the type 1 error, the equipment is safe, but it's decided to not be safe. Okay, there's consequences to that, right? So the reality is his equipment is safe, but he decides it's not. Well, he's gonna, maybe miss out on, a fun rock climbing trip or afternoon. When the truth is, he could have gone and he would have been fine. But let's compare that. So there are some consequences to that, but let's compare that to the type 2 error. The equipment is not safe, but is decided to be safe. Okay, so that could mean he might die, right? So he might be 30, 50 feet up, and he could fall, right? So that's, I think, type 2 here, much more serious consequences. Not to say that type 1 doesn't have any consequences, but nothing compared to the type 2 error here. All right. And you kind of think, like, maybe, going back to even his null, kind of my wind's blowing out, his null and alternative hypotheses at the beginning, maybe something was going on there. Like, do you want to assume that your rock climbing equipment is safe? And you have to be really convinced that the equipment is not safe, right? Maybe we could argue those should be reversed, but that's not the question, right? Which error has greater consequences? And in this case, it's definitely the type 2 error. Okay, so let's now do one on our own to wrap things up. Practice problem number 6. A patient arrives at an emergency room in critical condition and is unresponsive. The null hypothesis is taken to be the patient is alive upon arrival. I think that's a good null hypothesis. We should assume if they're unresponsive, we should assume that they are in fact alive. It's a good idea. So part A, what is the alternative hypothesis? Okay, so no big deal, right? We'll come up with the alternative hypothesis ourselves. So the null hypothesis is that the patient is alive. What would the alternative be? And you might say, you could probably phrase it in one of two ways. I went ahead and said the alternative hypothesis H1 is that the patient is not alive. But you might feel perfectly okay saying the alternative is that the patient is dead, right? Is not alive, the same as dead. I think you can make a good case there. Although in general, it's usually a good policy when you're doing your alternative just to throw the word not in there, just to be really safe. So if the null is that they are alive, then the alternative is that they are not alive, and then you won't get into any trouble. Although I think not alive, you could probably replace that with dead. Okay, so now what are we really getting after is part B. Which type of error has greater consequences? Okay, well, let's try and figure out what both errors would mean, and then we'll think about which one would have the greater consequences. So what would the type 1 error be in this situation? Okay, so it may be like, even how do you remember? All right, so think of it like this. The type 1 error is when the null hypothesis is true. The type 2, when the null hypothesis is false. So it's almost like the type 1 error, the reality is the null hypothesis. The type 2 error, the reality is the alternative. But then it's always that the opposite is decided upon. Okay, so the type 1 error is that the patient is alive. This is actually true, but is decided to not be alive. Right, but they always decide the opposite, right? Okay, so patient is alive, decided to not be alive. Think about the consequences, right? So the reality is this, but this is what's decided. That's got some terrible consequences, right? So this person's probably going to die because they stopped, the people at the ER stopped working on them. And okay, let's think about the type 2 error. Type 2 is where the alternative is the reality. Okay, the patient is not alive, but they decide the opposite, but is decided to be alive. Now, it's not to say there are no consequences here. Certainly there are, right? If they're not alive, but they think they might be, then they're going to give them attention when maybe they could be moving on to other patients. Okay. Perhaps, I don't know. Maybe they've got plenty of doctors at that moment, but usually there's people waiting in line at the ER from my experience. Okay, so, but, between the two, it should be really clear which has greater consequences. And in this case, of course, it's the type 1. If the greater consequences, the type 1, right? The person is alive, but has decided to not be alive. That is a bad situation. Now, if I could go one step further than just the answer to our question here, which is the greater, I'd like to ask this question. In general, which type of error is more likely to occur? Now, if you think about the way we approach the hypothesis test, right, we don't give a 50-50 chance to the null and alternative hypotheses, right? So we assume the null hypothesis, and we need a lot of evidence to convince us that we should actually reject it and move to the alternative hypothesis, right? So because it's not a 50-50, that means one of these errors is more likely to occur than the other. Which type of error in general is more likely to occur, the type 1 or the type 2? So if we were in class, I'd let people think about it and weigh in. Can't do that, so I'll just tell you the type 2 is much more likely to occur. Why is that? Because we assume that the null is true, right? So remember, the type 2 assumes that the alternative is true, but then it's decided otherwise. So the type 2 is more likely, error is more likely to occur because it's much more likely, because since we assume the alternative is true, we're probably not going to make the type 1 error nearly as often, right? The type 1 error assumes the alternative is true as well, right? We assume that's true. So it takes a lot of evidence to reject the null hypothesis, right? So to reject the null hypothesis when the null hypothesis was actually true is not going to happen very often. Not to say it can't happen. You might think you have a lot of evidence. You might have a lot of evidence, not think. You might have a lot of evidence and reject the null. And the reality was the null was true. But that's not going to happen nearly as often as the type 2 error when turns out the null is false, but yet there's not enough evidence to reject it. This happens way more, and that's a good thing. It's good that we have it set up this way, right? It takes a lot of evidence to reject the null hypothesis, so we're much more likely. It's much more likely that the null is false, but ends up still not being rejected just because there was maybe some evidence but not enough, just like in a trial, right? So it's a good thing to assume innocence and then not have enough evidence, even though maybe the person actually did it. It's better to let someone go who's guilty than to convict someone who's innocent. Um, at least that's the way our justice system is set up. Okay, that is the end of hypothesis testing with one sample.